Hi Year 10, this is part 1 of our paper 1 warm-up. So this week we're going to do paper 1 part 1 remotely, and next week, so I'll just write this in just for clarification, next week I will be doing a live lesson on P4 to P6. Now that's likely, or no, it will be, probably the first lesson on Monday the 15th. Now I will confirm the time closer to the point, and I'll have to practice doing live lessons, but if you want to tune in live, or of course you can watch it back later. But let's get started on part 1. So P1, 2 and 3, nice and simple breakdown. Now I tend to put all of these into one box, but there's so much in there I break them into two halves. There you go. So in the P1 we normally talk about forces, acceleration, so some of you will be remembering SUVAT or won't remember it at all, and we'll need a little bit of a reminder. Momentum, so we'll be looking at what momentum is. Newtonian forces, so Newton's laws 1, 2 and 3, you need to know them. And we'll be looking at energy, in particularly kinetic energy and gravitational potential energy. You do need to know all the other energy stores, but we will deal with these two in mathematical terms. So there's an equation for both of these two, whereas the others you just need to know what they're about, i.e. like tension. You don't need to calculate the energy transfer and tension. That's an A-level topic. However, you do need to know the kinetic energy equation and the gravitational potential energy equation. And we'll go through all those in this lesson. Once again, guys, you should be having 3 separate notes for these. Okay, and if you're trying these questions today and you're pausing it, you don't know what to do, then you need to work on your revision notes. You need to spend that time. Every time you solve a problem or something that's a bit tricky, go back to your revision notes and make sure those key points are there for you. It will really help your grades. Right, so this all came out to you guys earlier, about 5 or 6 weeks ago. And have a look and show my homework if you can't find it. And I put all 3 subjects up there, so biology, chemistry and physics, and paper 1 and paper 2. But I'm just going to concentrate on what you're going to be focusing on in 2 weeks' time. So we are going to sit a equivalent of paper 1. It will be multiple choice. It will be on show my homework, which actually makes it probably a little bit harder than normal, because you either know what you're talking about or you don't. It's not one that, whilst you can guess multiple choice, you've only got a 25% chance of getting it right. Whereas when you're writing down an answer, you put down something vague that might be in the right direction and you might get a mark. So you really do need to know your stuff to do well in multiple choice. So before we were talking about P1, 2 and 3, and I did say how I combine them together and they end up in different boxes. And if you look at the scheme of work, this is how they're actually broken down, how we teach them slightly differently, because these two tend to get taught at the same time. And then of course this is huge, so we break this into 2 parts. And we typically label one half as P1, one half as P2, and this one as P3. The good news is, next week when we do these are nice and straightforward for us, P4, 5 and P6. You should have a single piece of paper or A3 or a set of cards for each one of these. I don't mind how you do your revision, but you need to have these separated out, because we're going to concentrate on questions from P1. And then we're going to do questions from P2, and then questions from P3, etc., etc. And if you don't have notes for P2, or you're having to rifle through piles and piles of paper, it's inefficient. And I want to make you guys work more efficiently, not harder, if you get my drift. So have a look over those. Make sure your revision notes have everything listed here. And then you can always add to it if you find questions where you go, oh, okay, I didn't quite understand that. I could add on that piece of information. Right, so here is my first question. So what I'd like you to do is pause the video, go through them, and then unpause it and then see what I do. So I'll stop talking for about 5 seconds, and hopefully you can come back with me. Okay, so the answer for the first one is going to be a bit different depending on your train of thought here. The very first thing I teach people to do when they're answering a question, and they can identify, hang on, this has got speed, velocity, acceleration and timing. I think this is a SUVAT question. I get them in the very first instance, so I'm just going to put a little tail on that so you know it's the U. I get them to write down SUVAT vertically. And the reason I do that, and just to clarify, S will sometimes come up as X. It's just displacement, it means the same thing. We typically use S in SUVAT for every other exam board other than Edexcel, the one we do. So X just represents the same thing as S, and it's the distance. Okay? And this is our initial velocity. And feel free to scoot through these guys if you know all these. This is our final velocity. This is our acceleration. Most people can remember A for acceleration. And a nice easy one, time, T for time. And of course, time is in seconds. Acceleration is in meters per second per second. Sometimes that's shown as that, or it can be shown as that. They all mean exactly the same thing. I try to use this as much as I possibly can. At A level we use this, so occasionally you'll see me slip back to that one. But they all mean the same thing. Both velocities are always going to be in meters per second. And distance, because it's physics, will always be in meters. So you'll see lots of meters and lots of seconds and combinations thereof. So there's no tricks or traps there. They might give you something in kilometers, then you just change it to meters. They might give you something in minutes, you just change it to seconds. Okay, so we have 3 SUVAT equations, and the one you were looking for, V equals U plus AT. This is the one you must know. Now, it is sometimes shown as V minus U over T, okay, on the equation sheet at the back. I find this much easier to remember, but that's just from experience of what most people experience in terms of remembering recall. If you have a better way or you prefer to remember this, that's absolutely fine, because all this is a rearrangement over this side of this. So, however works for you. Now, the other 2 SUVAT equations are always given to you on the equation sheet. Now, they can be in different formats, so they're just rearrangements. So, occasionally you'll have V squared. It could be V squared equals U squared plus 2AS, or it could be V squared minus U squared equals 2AS. Now, all they are is a rearrangement of each other. And what I was talking about earlier, this lovely thing with X, it might be, instead of an S, I'm just going to cross that S out, it might look like that. All it is instead of X SUVAT, that doesn't really work, instead of the S, it's an X, and you just put the distance in there instead. It's no different to how to use the equation, it's just a different letter. And finally, S equals UT plus half of AT squared. Okay, again, that could be X instead of S. Alright, so the 2 most common ones are the top one that you must know and be able to recall, and the second one, because it's on your equation sheet, they'll never give you a question as simple as find the velocity and then give you all the other information. It will be something like find the acceleration or find the distance. Something that requires you to show you can rearrange the equation, as simple as that. So, we're going to rearrange the equations. So below, if this is something that you're really good at, let's move on to the next bit. But I'm going to do it step by step for you. Find my pen, there it is. So I'm going to start with, I'll move over here, I'll draw a line, nice and big space for me. I'm going to start with the equation, plus AT. And for the first one, I want A. So I'll put a little line underneath A, so I know it's the bit I'm after. And if I need to get A on its own, I want to do reverse bid mass. So I want to do all the things from the SAM, yep, DIB. That's quite hard to spell backwards quickly in your head. But I want to do the subtraction and additions first. Well, straight away, what's added or subtracted to the A? Well, this U. So let's get rid of this U. So the opposite of a plus U is minus U. So I'm going to minus U off both sides. which means I've now got minus v minus u equals at. Okay, that's straightforward. I've still stuck with this t, and it's multiplied, okay, because there's no gap in between. And the opposite of multiply is divide. So I'm going to divide by t because I want to get rid of it. But if I do that to one side, I must always do to the other side. Okay, and because I've got t up the top and t down the bottom, I can cross them out. And straight away I've got a equals v minus u over t, which is ironic because we already had that up there anyway. But, so I'm going to transpose it over here. And this is a common one that you'd need to use, or v. Okay, it's just moving letters around. Now, if we do the same thing very quickly, if you can have a go this time getting t, pause the video. I won't stop. I'll keep going through. So if you want to pause the video and have a go at doing t yourself, then you'll know whether you've cracked this or not. So I want to minus u from this side. If I do that to this side, I must do it to the other side. So v minus u equals at. I want to get rid of a. I want to put a on the other side and get t on its own now, because I'm trying to get t. So v minus u. Oh, I skipped a step. So I want to actually divide that side by a. So I divide that side by a. These two a's cross out. So v minus u over a equals t. And I'll write that in over there. And those clever cogs amongst you will notice all I've really done, is to swap those two letters around. Because they're multiplied together, it's just a case of swapping them back and forth. Really handy thing to remember to save a bit of time. As long as you can remember it's v minus u over something, you'll be 99% of the way there. You can't be too wrong because it'll either t over a or a over t. You get exactly the same answer. So well done. Let's move on to the next one. Okay, so this is a fairly common question. They've given you a diagram over on the right hand side, and straight away they're giving you some of the information but not all of it. Remember what I said the very first thing you were going to do with a SUVAT question? Well, we're going to write down SUVAT, and we'll do that up here. We might not necessarily be using it all just yet. We're going to do it anyway because it shows good practice. Okay, so the very first question, what is the velocity at this point? And they're talking about at point B. Okay, so they're asking us what is the velocity here that comes out. Well, the only way we can do that is doing velocity equals distance divided by time. So velocity, I will write that in here. Let's do the space. Velocity equals distance divided by time. How far you go and how long it takes you. So straight away, our distance, there we go, is 10 centimeters. So we need to change that to what? Meters. That's right, because we don't work in centimeters in physics, we work in meters. So our distance is 0.1. The time it takes us is 0.2. Okay, so if I get my trusty calculator out and do 0.1 divided by 0.2, I would get a lovely half a meter per second, or 0.5 meters per second. Okay, which sounds like a fairly reasonable speed. It's not a massive tube by the look of it. Okay, so that seems fairly reasonable. If I got an answer of 450 meters per second, I might be thinking that's a bit quick. Okay, so question 2, which velocity is this, initial or final? Now, this is where people sometimes get themselves in a bit of a pickle. What does initial and final really mean? The easiest way to remember is this is the start of the question, and this is the end of the question. And if we're dealing with accelerations, etc., the ball stops accelerating here. The only time it accelerates is between these 2 points. So our SUVAT is really between A and B. We're not going to read. The only thing we can do after here was what we did right at the start, velocity equals distance over time. This isn't SUVAT. This ball would actually be slowing down, but we're allowed to ignore that at GCSE, and we were asked how fast is it going at point B. So what we're really looking at is point B being the end. So it would be the final end of the question, would be the final velocity. So I'm going to add that up here. because I think that's important to put that in now, because we now know that's 0.5 meters per second. When we let the ball go right at the start, right at the beginning, the speed of the ball, it's stationary when we first let it go, and then it starts to accelerate. So its initial speed is actually going to be 0. Okay, that's pretty handy to put in. Are we given a distance that the tube is? No. So if we haven't been given a distance that the tube is, we're going to put a cross there. We don't know that. It hasn't asked us. And what is actually, here we go, 2.4 seconds. So we put 2.4 in. And what it's asking us is, what is the acceleration? So let's put a question mark. Now this is very typical of a GCSE question where you have 1, 2, 3 pieces of information, a question mark and one unknown. Okay, straight away we don't need that one. Okay, we've got everything else we need, and this is why I get people to write SUVAT, because now we can go, okay, I've got a U, a V, an A and a T, which means I need one of the SUVAT equations that doesn't have an S in it, or an X in our case. So UVAT, well actually that's the first one, isn't it? That's the one we need to know. So let's write that one down. V equals U plus AT. Great. But I need to know acceleration. Okay. So at least I got the right equation. I need to rearrange it. So I'm going to have V minus U over T equals A. And we did that pretty conclusively in the last slide. So look back into that one if you can't remember how I did that quickly. And let's put the numbers in. So straight away, because I've already done this, I've taken all the risk out. So if I make a mistake here, the examiner can go back to this and go, they've written this down as 0.4, but they reused it, so I'll give them carry forward error. If you don't do this, and you get this next bit wrong, they won't be able to tell where you got it wrong, and therefore they won't be able to award any marks at all. So this is a great safety net. So our final velocity was 0.5 minus our initial velocity, which is 0, over our time, which is 2.4. So we've got 0.5 divided by 2.4, which is going to be around about 0.2. Let's put it in the calculator. Divided by 2.4. It's 2.1-ish. Okay, so I'll round it up to 0.21. But we're not done. Okay, it's acceleration. We need a unit for acceleration. And we will write meters per second per second. So this is a really good example of how to pull a question apart, solve it, and put it down. And also, if you're not sure, if you start making mistakes during the question, well, here we go. We would have got a mark for up there, and all we had to do was write down the information from the question. We would have got a mark for the equation. Okay, straight away, we're at 2 marks. This might be worth 3 or 4. Okay, if we make a mistake in solving it, alright, we're not going to get that mark unless it's a carry forward error, but we might get that mark for carry forward error. We might get a mark for rearranging, and we'd probably get a mark for solving. So there's lots of marks that you can get without actually getting it all correct, but it's important that you follow the step-by-step process to get those. Okay, so forces, question 3, quickfire SUVAT. So this is the equation that you'd be given. So we're going to have to rearrange it. So pause the video, have a go at rearranging it for what you think you need, but straight away, let's see some SUVATs being written, and come back to me and I'll go through and solve. Okay, so if you're back with me, first thing I'm going to do is S, U, V, A, and T. My distance is 1,500 meters, so that's in the correct format. My initial velocity is 12. My acceleration is 10. And my distance, initial velocity, acceleration is 10. They're asking me what my final velocity is, so that's my question mark. And they haven't given me time, so let's cross that out. I don't have time. So straight away, I need an equation SUVAA, and it tells me already to use v squared equals u squared plus 2as. So let's v squared equals u squared plus 2as. And I'm being asked to find out what the final velocity is. So I need v on its own. At the moment it's times another v. So I need to square root this v, which is fine, I can do that. So let's square root that side. Now if I square root that side, what must I do the other side? That's right, I have to square root the whole thing. Common misconception is people start just square rooting the u squared. No, you've got to square root the whole other side. So now I have v equals square root of u squared plus 2as. Bigger to make it obvious. Let's put the numbers in now, as we've done all the hard work. 12 squared plus 2 times 10 times 1,500. That's good practice to show it all the way over. Put it all in your calculator in one go. That's good practice in its own right. So let's do 12 squared plus 2 times 10 times 1,500. Hit the calculator. I'm going to get 100. I'll write this in as I go. 170. Does it give me? Oh, 3 significant figures. Oh, gotta watch that. So I only need the first 3, and it rounds up to 174 meters per second. Don't forget the unit. Okay, so question 2. Rearrange the equation for distance. Okay, so I'll have a crack at that. I'll write it up here. V squared equals u squared plus 2as. Pause the video. See if you can get it s equals. Make s the subject. Okay, I'm going to keep going, so hopefully you pause the video and had a go at it. So v squared minus u squared. I've just moved the u squared to the other side, just like the other equation, to as. I'm trying to get s on its own, so I'll just underline s. So I'm going to divide this side by 2a, which means I need to divide that side by 2a. These two 2a's cross each other out. So s equals, ooh, that's a v. I'm just going to cross that out. V squared minus u squared over 2a. Okay, that's fairly straightforward. So we've got another SUVAT question here. Let's carry on. So that's SUVAT. So what are they giving us? Final velocity is 100 meters per second. Initial velocity was 0.5. Acceleration is 10. Time they have not given us. S, they're asking us what's the distance travel. There's our S question. Oh, what a coincidence. We've already been asked how to do this. So because, oh, I've already got that up there. I might have indeed written the whole thing out. So I'll just put complete completion. Yes, I did just say that. Let's write this out as we've already rearranged it. So v squared minus u squared over 2a. Now we can just drop the numbers in. So for v, we've got 100 squared minus 0.5 squared over 2 times 10. And if we put that all in the calculator, let's see what we get. So I would use the box button in this instance, or fraction button. I never know what it's genuinely called. Use that button in your calculator. It makes it easier and less likely to make any mistakes. So 100 squared minus 0.5 squared over 2 times 10. And that comes out at, ooh, a nice round. If we go to 3 significant figures again, 3 significant figures, that would end up at 500 meters. So well done if you got that. So guys, you'll have access to this video and it's a great practice to go through the SUVAT quickly. Okay, so it's pretty common to get a graph and be asked what's happening on that graph. And there might be a few of these in your end of year test. This is one I enjoy because it's a bit of fun, and I will tell you what the answer is at the end. But let's go through it step by step. So pause the video. I'll come back in about 5 seconds and have a go at these, see what you come out with, and I'll quickly work our way through. Okay, so if you're back with me, describe the velocity between point A and point B. People get themselves into a pickle because it's a curve. Well, if I kept going at a constant acceleration, by point B, I would be on this dashed line that I'm just drawing in. So it's still accelerating, still going faster. Okay, so velocity is increasing. So acceleration is positive, but the acceleration is but it's slowing down at its rate. So acceleration is reducing. Okay, so there's quite a lot to what's going on there. So we know velocity is going up because we were there on velocity and we've gone up. Okay, so it's getting faster, but the rate of which it's getting faster is reducing, but it's still going faster. So these are quite tricky, and it would be more opportune just to draw some arrows there and go, okay, what's velocity doing? Velocity is increasing. Right, as I will say, velocity is increasing. So in a written answer, write down what you see as you work it out. So if the velocity is increasing, acceleration must be positive. Okay, so if there's a minus acceleration, velocity would be reducing. Okay, not going up still. So we're still going faster and faster and faster. It's not as fast, so it's reducing. Could we use SUVAT to calculate the acceleration? We've just said the acceleration is reducing. SUVAT is known by another name, the constant acceleration equations. Is our acceleration constant? No, so no, we cannot. Okay, and that's all because of constant acceleration. What one word describes the velocity at point C? Okay, so point C, roughly in there. Well, velocity hasn't changed. It's constant. And that's the only word you really want to be using in this context. Constant is not changing. Point 4 suggests what might be happening at point D. Wow, all of a sudden, we are massively reducing our velocity. It's plummeting. Okay, our acceleration is a minus acceleration. We're going slower and slower and slower and slower. And any ideas what this graph might represent? Well, I'm just going to tell you. I might usually make a class guess for ages. This is somebody skydiving. So this point here is where you jump out of the aeroplane and you go fast. You get fast really quickly, but you don't keep going faster and faster and faster and faster. In fact, the air resistance keeps getting higher and higher and higher. So eventually, you end up on this nice curve. Now you get to this point C, and this has another name. Terminal velocity. This is as fast as you can go as a skydiver. There is the air resistance equals your weight. So force due to gravity, because you still have weight, you just happen to be falling, and you've got air resistance. When they two of them cancel each other out, you end up at a constant velocity. You can't go any slower or any faster. And of course, when you pull the parachute, you get a huge change in force. So your air resistance increases massively. You still got weight, that hasn't changed. But because you've increased that air resistance force, you end up with a negative acceleration. You're going to slow down. I'm not entirely sure why I think that's this point here is E is when you slow down as much as the parachute will let you. And then of course eventually you would go plunk onto the ground and be stationary. Well done if you guessed that. Okay, so we're into the P3 stuff here, guys, but I want to make a point and get you to ask this question down the bottom. Okay. Does this all marry up? Well, it should do. Otherwise, we can't say one thing is correct and the other thing is incorrect. But let's prove it. So, pause it for me. We're going to use the energy equations. So, very quickly, just to remind you, kinetic energy equals half of the mass times velocity squared. And gravitational potential energy equals the mass times the gravity times the height. Sometimes that's shown with a triangle in front of it. It just means the change in height. But if you remember those two, these are non-negotiables. These are the ones you must be able to recall. They're on every revision sheet that I've given you, but make sure they're on your revision sheet that you've made. So what I'd like you to do is pause, work your way through 1, 2, and 3 on the left. And also, we've done lots of SUVAT in this lesson today. Have a go at the SUVAT on the right. Pause, and then I'll pull them apart and show you how I would figure it out. Okay, so if you're back with me, so first of all, we've got a stationary rock, 15 kilograms, it's 12 meters off the ground. How much energy does it have? When we're not talking about it moving, so hence stationary, we want to know its gravitational potential energy, and I'm going to write out the formula. It's always a good habit, write out the formula just in case you make a mistake, but also helps you put everything in the right place. Its mass is 15. We've been told to use gravity equals 10. Its height is 12. There you go, straight like that. 15 times 10 times 12. No, I'm not going to try and do that in my head. Let's get a calculator. 15 times 10 times 12 comes out at 1,800. That's why you don't do things in your head, because I was going to guess wrong. 1,800, and it's an energy. So all energy is in joules. Capital J for joules. Right. So the rock falls and converts. We're on to question 2 here. The rock falls and converts all of its GP to kinetic energy. How much kinetic energy does it have? Well, if we take all of this energy, so 1,800 joules, and we've said this is all turned into kinetic energy, we can now say kinetic energy equals 1,800. Okay, that's fairly straightforward. So we were asking about how much energy, kinetic energy, does it have now? Well, that's easy. 1,800 joules. We'll just change it from one thing to the other. However, this is where all the marks are hiding. Can we work out how fast it's going? Well, from GPE, no. We don't have anything about velocity in GPE. It's just mass, gravity, and height. But in kinetic energy, we do have a velocity. So let's write out what we do know. Let's use a kinetic energy equation. Kinetic energy we know is going to be 1,800, because we've already said that. We know that the mass isn't going to change. That's the one nice thing about this. The mass is still going to be 15 kilograms, and the velocity is our question mark. Okay, so let's write out the kinetic energy equation. Let me find a spot where I haven't scribbled. So kinetic energy equals half times the mass times velocity squared, and I need to get a single v on its own. So straight away I want to divide this side by half m. So if I do that to one side, I have to do it to the other side. Half of m, which leaves me crossing out half, m and m. So I've now got v squared equals ke over half of m. If I want to square root this side, that's fine. So if I square root this side, I'll get rid of that too. And if I square root that side, I have to do that to the other side too. So I now have, and I know this is starting to get a little bit messy, I'll make some space over here. I now have V equals kinetic energy over half of m. All of that is in the square root. So let's put in the numbers. Kinetic energy was 1,800, and mass hasn't changed. Mass is going to be 15, so half of times 15, and remember the whole thing is square rooted. And we can put that in our calculator. Now, a couple of tips for you: don't try and put half as a fraction, just put 0.5, it'll be much faster for you, and use the fraction button to build, use the square root and then the fraction button to build all this. So 1,800 on the top line, on the bottom line I've got 0.5 times 15 equals, and I have a velocity of, where are I? Lost my pen. 15.49 meters per second. Remember, it's velocity, meters per second. Okay, that's using energy. Let's do it doing SUVAT. So hopefully you've had a crack at doing a SUVAT, and hopefully the very first thing you did, S, U, V, A, and T. People always ask why I use lowercase for t. It's because time should be lowercase t. Capital T means time period. So if we're talking about frequency, for example, we're often talking about how long it takes something to go up and down again. So anyway, that was a bit of a side note. So we are talking about falling 12 meters. Its initial velocity is 0. Its final velocity is unknown. We'd like to know that and confirm that this is correct. Our acceleration due to gravity is going to be 10. And the time, we don't have the time it takes, so we don't have that one at all. So we need an equation that does not have time in it. Well, there's only one of those, and this will be on your equation sheet. V squared equals U squared plus 2AS. So there's your hint. Look for something without time in it in the SUVAT, and we want to know what V is. Well, this is nice and easy. We just want to square root V squared. So if we square root V squared, it becomes V, but we've got to square root the whole other side. So U squared plus 2AS, that's probably the easiest rearrangement you'll ever get. And now we put the numbers in. So our initial is 0. 2 times, what's our acceleration? 10. And our distance is 12. So we know that 0 squared is 0. So we've got 120 times 2, so 200 square root of 240. I have a sneaky suspicion this might be very close to 15.49. So square root 240, it equals, and strangely enough, it is 15.49 meters per second. So there is an example, guys. This has been Newtonian physics where we can show something using SUVAT, or we can use the energy equations. Now, the energy equations does take longer. It's in 2 halves. You've got to work out gravitational potential energy, then transfer it all to kinetic energy, but you might not have the information required to use SUVAT. So here is an example of solving multiple problems multiple different ways. And that's great practice anyway, because if you make a mistake, the 2 answers will be different and you know they should be identical.